my talk on scripting. I hope you guys are here not because of a hangover from yesterday's Nestor's bar, but because you love scripting the way I do. My name is Pontesegger. I'm the project lead of the Eclipse scripting environment and scripting project, which I'd like to present to you today. I want to show you one single slide that we all understand what this EASE project, Eclipse Advanced Scripting Environment, is all about. And then we step immediately to live demos. Because I'm a technician, I do not like slides, I like live demos. So we all know we have this beloved IDE called Eclipse, which has great support for different scripting languages like JavaScript by the JSDT framework, or for Python scripts using PyDev. There's support for Groovy or Ruby scripting. What all these additional projects have in common is they provide ways to write those scripts, like editors, code completion stuff, project infrastructure, and things like that. But when it comes to executing scripts, they rely on an external interpreter typically. So they start something outside of Eclipse, run it, and the best thing you can get is that you get the output back in your console view. On the other hand, we have nice script interpreters like Rhino or Python that run natively on your Java runtime. But they are not hooked together with the scripting projects like JSDT or PyDev. So this is what EASE is all about. EASE is a glue over the environment that allows you to write and maintain scripts, and on the other hand, to execute them on the same JRE you are creating them. So I told you this is just the one slide. Now we step directly to live demos. As I'm going to enter a lot of text up here, is it readable in the back, or should we enlarge it? It's okay? Perfect. So what you can see here is a default vanilla Eclipse. A little bit increased, so I have to zoom in then. Just remind me from time to time that I do it. What you see here is a vanilla Eclipse with the EASE framework installed into it. You can get it from eclipse.org/EASE. There are all the download locations. What you can see on the upper side is a scripting shell. This is an interactive interpreter, like a DOS console, for example, where I can enter one-liners and get immediately feedback on your result, like this. So the obvious first thing to do is the hello world. As you can see, hello world returns now, and the output goes to the console. So what you can see here, what we use here, is the Rhino interpreter that runs natively on the same JRE that Eclipse runs on. What this gives us is the possibility to access all Java instances, all Java classes that can live inside that JRE. To give a short example how this works, I can, on the fly, create a new Java IO file instance, for example, and work upon its methods live in the editor. Now, when it works for classes from the runtime, the next obvious step is try to use a class from Eclipse. So we can immediately live access our platform instance, run methods on it, and execute everything you can think of on any Java class that exists on our runtime. Now, for the first thing is, okay, I can access Java classes. It's not the big deal. So why is this so important? When we step back a little and think that you can now manipulate anything that lives inside your IDE, think of the power you get. You can automatically import Git stuff, if you like, for example. You can automatically open up views. You can change your workspace dynamically using scripting live in your system. This doesn't only work for classes from the runtime or from Eclipse, but it works for any class that you can access from any Java file you would put into the Eclipse universe. So if you have your dedicated RCP that provides its own plugins, you can access them from the script shell. So it can provide easy scripting access for your users. Now, if that is not enough, and you might think you have external libraries you want to use, you can simply hook them into your scripting environments. So we have some loading mechanism that can access external jar files using URIs. So they can be hosted in your workspace, they can be hosted on the web if you like, load them dynamically, load it in a system, and execute commands on them. So the next idea is, as you can see, I can not only data in the script shell, of course I can write it into files and execute those files, for example, using launch targets. When I can launch the stuff, I can also debug it. So we have our own debugger support for the script engines we support. When you think of writing automation for Eclipse, when you need, let's say, 10 to 20 Java classes, you can see we always need that full qualified path name here to access those classes. This gets quite messy. You have long code to type. We have some kind of code completion, but it's not as good as you know it from JDT. So we needed to find a better way, an easier way to access common functionality. The way we do it is by providing so-called modules, which basically are Java libraries in the background that provide some functionality we want to expose to scripting. So modules here are not loaded automatically in the workspace. So the bare script shell, as you have it here, has only support for around 10 basic commands we allow, like that load jar or that include you might have seen in the scripts. When I want to load functionality for UI interaction, for example, I have to load the UI module by using the load module command. So from that point on, I have all those commands you can see listed here on the right-hand side available in my script shell. So I can say clear console, for example, and the console is gone. Now, if you run Hello World UI, you can pop up dialogues and all that kind of things. You can open, closing views and stuff, interaction with the UI. We have also modules for interacting with the workspace, with resources. What we can do is, for example, we can create a project on the fly. Let's do this quickly. And I have two different versions of this script available. So on the right-hand side, you see the script using pure Java access. So this is how it would work without using modules here. On the left-hand side, you can see the same functionality, create a project and 3 files within that project, with the power of modules. So basically, the only thing you have to do is ask the user for some nice project name, create a project, and write some files in the for each loop. Let's try this out. Let's close this one. It creates a project called EclipseCon 2015 sample project. Let's do it, and voila, you have your new project in your workspace. The next module I'd like to show you is a platform module. The platform module allows you to access services, for example, from Eclipse. So if you need a handler service and that quick, you can use a getService class and you do not have to step through the runtime classes. It gives you access to preferences. It also gives you access to the external process interface, so you can start external executables on your system and fetch the results from them. I'm leaving the getService. You can imagine how to get a service. What I'm doing right here, I hope the network is working, right? I'm doing dynamic ping statistics by calling the ping command and displaying them in an interactive chart. So it takes some time until the servers are gone. So you can see you can work very interactively with scripting. Okay, done. Let me clean up my workspace a bit. So the next thing what we have is, I showed you the Rhino script shell up here, which hosts a native script interpreter. We can have multiple interpreters in the system. So this is not one script engine running for each and every script in your workspace. You can have as many script engines you like, which are separated in a sandbox from each other. What you can do with it, you can start multithreading, for example. So we have the possibility that one script launches another script, and they run simultaneously. Let's check this. So you can see we are spawning 2 threads here, waiting until they're done, and end our master script. So you can see that they nicely align on each other. Each script has just a simple loop to print something and to wait for a little delay in between. So how does this all work? How do you get your modules? The main reason why I show you this is Ease doesn't understand itself as a project that will provide modules for each and every Eclipse plugin out there. So if you like EMF and you want an EMF module to be there, Ease might be some kind of incubator for it where we can start developing it. But in the end, I do not want Ease to have dependencies on each and every Eclipse project out there when I want to build that stuff. So how do you write your own module? First, I'd like to show you how the module mechanism works in the background. I'm creating a new file instance, as I did that before, and bind it to a variable. Now I have this mighty command called wrap, which takes the file instance, parses it via reflection for all its public methods, and makes these methods available in the scripting environment. So it creates scripting code to access that Java instance dynamically. After that, I could, for example, call the class create, or the method create temp file, which is a static method defined on the Java.io file object. And you can see without the knowledge of objects and how they work in the background, I have an easy and usable interface how to interoperate with Java. Now, when I want to write my own module, how would this look like? As you can see, I've used a Java.io file object that has nothing special in it. The easiest way to write a module is to write a pojo. So this is the simplest form of an Eclipse module, of an Ease module. You just see we have just public classes, we have some static member fields in there. And the only thing to do for you when you have such a class is you have to provide an extension point. It only takes an ID, a nice name that we can reflect in the UI and which we use for the load module command, and it provides the class instance. That's the minimum you have to do to create such a module. So we've seen the simple calculator has some methods like add, sub, mul, and diff. This is exactly what you get here on the right-hand side. These are the 4 methods available in the system. You can load the module and use its commands. If you want to have more control on what you are exporting to scripting, you can use our dedicated annotations, wrap to script. As soon as you start using such an annotation in one of your exported modules, we are only exporting public fields and public methods that have that annotation. With additional annotations, we allow you to provide optional parameters. So these parameters are optional for the JavaScript environment or the Python environment you're using, but they, of course, are mandatory for the Java class. So we fill them with the default values you provide here. Modules then can also have dependencies on each other. So we can say the advanced calculator module depends on the simple calculator. So what we guarantee is when you load the advanced calculator module, the simple calculator module will also be loaded, because maybe you need it as a dependency in your scripts later on. Okay, and now the basics are done, and I'd like to show you what you can do with this in practice. So the very first thing we use quite a lot in the company I work for is unit testing. We created a simple add-on to scripting that allows us to write unit tests in script code. So what we provide are simple methods like start and test that denote a test entity, and we provide assertion methods that give you the typical results. So you have assert true, assert false, assert null, all the things you might know from JUnit. Additionally, we provide a very easy way for you to provide your own assertions in your modules. The only thing you have to do is, on an exported method, you have to use a dedicated return type or derive from a dedicated return type. Then the system will automatically pick your method up as an assertion method and create reports on this. To launch tests, we use a so-called test suite, which is basically an XML-based file in the background. You can define your tests there. Which files do you like to run? You can define how much simultaneous threads you'd like to use in your system. You can define variables that are automatically available to all your test scripts that are launched from that test suite. And you have your dedicated injection points for code like test suite setup or test file teardown, as you might know it from JUnit. Let's run this one. And you can see you get a few very similar to what you might know from JUnit. So you get your test results. You can click on any test, so you have the link to the source files and the source locations where you run your code. And you can create reports out of it. Reports are using the JUnit format, which can be picked up by your Hudson or your Jenkins automation server. What you also can do is you can run scripts headlessly. So this means you can have a script that starts and launches your test suites, creates a report out of it, stores it, and this can all be done on a nightly integration. I'm working for a semiconductor company. What we do with this is mostly hardware testing. So we have a lot of testers that do not have extensive knowledge of programming, so they have no idea of object orientation or things like that, but they do understand the simple command interface that we provide to them. So they can provide their test and their test flow on itself. So when you know what to do with scripting, and when you know how to write scripts, the next thing you might want to do is build up a script library. You have your most beloved scripts, maybe 10 of them, maybe 50, you use on a daily basis. You might not want to store them in the workspace, or you might not want to launch them in the way I showed you. So one way to do is we can define locations where we search for scripts and make them available, more prominent in your IDE. So we have that script location, preferences. You can add locations from the workspace, from the file system, or even from a web server if you like. So we don't care where you host your scripts. They can be hosted outside of Eclipse and outside of your workspace. So you can share them with your department, for example, or have a company-wide share web server wherever you can want to host your scripts. So what I'm doing is I'm taking the modules folder where we had just the nice examples in there and say, I want these scripts to be more prominently available. And what happens is the Script Explorer parses that folder, that location, and shows me all my scripts. So we have that Hello World UI that simply pops up. If you double-click it, you can run the script directly from the script shell. The same thing, the same view you have in the Script Explorer, you already also have in the shell, where I can execute the same scripts in the context of the script shell. So you can see we create a dedicated include here. This is different to that one here. A separate thread is started. You can also edit the scripts, of course, from here. And what you can do now is, for those scripts we host on such script locations, we look into the scripts, and if the very first thing we find is a comment, like here, we are parsing for key value pairs, and some of them have meaning. Let me show you what this means. So if I put a name parameter in there, and store the script, just look at the Script Explorer while I click Store. You can see the name, the appearance of the script is changed in here. This doesn't mean that we change the file name or even the location of the script. We just change how you can look at the script, how it's represented for you. You can also provide folder hierarchies if you like to create your own dedicated view on scripts. And this is just the beginning. So where fun starts is if you have a script that you need on a daily basis, but you do not want to start it from the Script Explorer, we allow you to bind that script almost anywhere in the UI of Eclipse. So what I can say is I want that script to be available from the toolbar of the Project Explorer. So look at the toolbar up here. And you see my script is dynamically injected into the toolbar. Via click, I can run it from here. You can also bind to the menu of a view. And what I like most is to bind scripts to pop-up menus. So what we can say here for a pop-up, we can either provide a view where we want to bind it to, or we can provide dedicated objects we bind it to. So I can say, I want this script to be available only for, let's look, org, Eclipse, core, thanks. That's why the code completion did not work. Bind it to iProjects. So here's my script. You can see on folders, it's not there. So to have a more elaborate example on this, I can use, where is it? No, here. I have a simple script called explore from here. Now I'm putting it into the monitored folder. And what you can see is the explore from here scripts. Let's look at the code. It has a lot more of those keywords in there. So for example, an image. Instead of having the name in the toolbar, I now have a nice image in there. You can also provide the script type, which helps us a little to find the correct engine to execute the script. Normally it's not necessary, but if you want another file extension like JS, for example, this would be necessary. You can define script engines to run on or script engines you want to avoid. And basically what the script does, it just gets the current selection, tries to find out if the current selection is some kind of container, and if we find a container for it, we launch the Explorer on this. So I can go here, for example, to the script shell, right-click, explore from here, and launch an external Explorer. I know there's a dedicated plugin available in the marketplace, I guess, for the same functionality, but now I can do the same thing with about 10 lines of code, dynamically. Okay, next thing I'd like to show you is more interesting for developers out there. We're not only allowed to write scripts in script languages like JavaScript, we also allow you to write scripts in pure Java if you like to. So you can have a Java class where you do something and bind this as a script in your environment. So you're not bound to JavaScript anymore. You can write plain Eclipse code if you like and just try it out live in your IDE. To show you how this works, I'm loading a dedicated module called JVM, which gives us nice methods like compile to get the class of an object, or to create an instance directly, or to invoke a dedicated static method on a class. I have here a simple Java project with a test class. So the test class is very simple. It just uses display. So you can see we are using SWT here. We have dependencies on other packages in here, and we open a simple message box. Let's try to load that. So you might have mentioned we have dedicated resource schemes like workspace, like project, like script, that allow us to select files in the workspace and so on. We are not relying on the resources locator that you might know from Eclipse, which would also work if you would like to use that. So I hope I have no typo. One. So I dynamically created an instance of my test class, which lives in my workspace. And now I can call its main method. To see that this is really live, let's change something here. Create a new instance and run it. So the interesting thing is I don't have to launch any more a new IDE, a second one where I can test simple stuff. I can run it right in my IDE without launching a separate Java process in the background. Okay, let me step back to the slides. I'd like to give you an overview of what we've just seen so far. So you have seen the interactive script shell that allows you to execute code. We can do this in different languages, by the way. This I didn't mention before. So the script shell has the opportunity or the possibility to change to a Jython interpreter or to a Groovy interpreter, if you like. And all the things you have seen, like modules and loading modules, works for all script languages. So if you write a module, it's available for all the script engines you can host within ease. So we saw the access to Java, the runtime. We've seen that we can load external jars, and of course anything from the Eclipse universe. We have code completion in there that helps us for Java classes. Currently, we are also working hard with the JDT team to get the help of JDT into ease, into all the interpreters, into JSDT, into PyDev, and all the IDEs we support, and editors. We have those modules that we provide from the system. We encourage you to write your own modules by wrapping Java objects in the easiest way, registering a simple Pojo class, or writing the more sophisticated modules using the wrap to script annotation, if you like. I will publish the slides. The slides will have lots of links to detailed tutorials how to do that, step-by-step guides. What we do for modules, we are creating documentation for them, and we are creating them not manually. We have a dedicated Java doclet that we use that we can hook into a Taiko build. So we create documentation on the fly during the build, and therefore the documentation is always consistent to the module we deliver to the customer. We have launch support. I briefly said that we have debugger support, so we have our own debuggers for JavaScript and for PyDev, or for Python code. You can create script libraries, record your scripts if you like to run them. You can share them anywhere you like. That's an important thing. So normally when you write scripts, you want to share them with your colleagues or with your teammates to collaborate. You can enhance your UI stuff. We've seen the live charting feature. We've seen the scripted unit test, which is tremendous powerful if you use it for verification and have your non-skilled programmers that want to do the testing. We've seen that we can interact live with Java without launching a new JRE. And that's the current status of which engines we do support so far. So what we basically need when we want to introduce a new engine into ease, we rely that it has access to Java objects in any way. So currently we are using interpreters that run natively on the JRE, but technically we are not bound to that. So for example, currently we're discussing about Python support in general using modules like Py4j or JEP. These are two technologies that allow Python to interact with Java code. So we could also have external interpreters that we use in our system. So yeah, that's why I love scripting. If you want to get in touch with the project, look at eclipse.org/ease. That's the main project page, or look at my blog there. I have lots of tutorials how to use that, provide news on the topic. And that's it for this talk, so I'm open to your questions.